Hi, my name's Abesh, and I'm here to talk to you about a revolution in LCD video wall technology. For those of you that are familiar with LCD video walls, you would know that there's a number of challenges that you face when putting up a video wall. And for those of you that don't, you're about to learn what some of those challenges are. First and foremost is the thickness of the bezel. The bezel is the plastic edging around the screen. As you can imagine, in a tiled video wall application, you're putting these screens together, so you've got to consider the thickness of the bezel, as it can be really distracting when you've got content flowing across the screens. Secondly is the calibration and the color consistency across the screens. Now, by nature, LCD panels tend to drift. So on day one, when they're installed, everything looks perfectly consistent across the video walls. But as time goes by, you would start to experience some sort of a checkerboard effect. And some of the panels will look slightly bluer, some of them would look slightly pinker. Obviously, this can also be really distracting and creates a bad impression of the technology as well, and for your brand. So what you want to have is an ability to calibrate these screens. Most professional video wall LCDs would allow you to calibrate them, but this would typically be a manual process. So it requires human intervention, a human being standing at each single screen with a sensor that will read the color values and the brightness values of each screen. That information is passed back to a PC, and the PC then tries to compensate for all these differences within the screen. Wouldn't it be better if you had a system that was completely automated and didn't require any human intervention? Obviously, this would make a lot more sense. Thirdly is the alignment and the serviceability. Let's use an example of a 3x3 video wall, and let's consider that the screen in the center has failed. What you want is a system that is not going to destroy the alignment that the installers have spent hours trying to perfect in trying to get access to the screen, service it, and replace it. So what you want to have is a bracket system that will allow you to easily access the affected screen, service it, replace it, and maintain the perfect alignment, not just on the X and Y axis, but on the Z axis as well. The next important element is heat management. Most professional video wall screens will have some sort of advanced heat management, and this could either be in the way of having temperature sensors that would turn fans on and off, or you could have a completely fanless design. Now, the reason that heat management becomes crucial is, as you all know, heat rises. So the screens that are in the top row of your video wall obviously have a lot more heat to deal with. They're generating their own heat, but all of the screens from the bottom of the video wall are passing their heat up to the last row. So heat management becomes really important. A typical LCD, a consumer grade LCD, doesn't have any fans in it. It's not designed to be used in 24/7 applications where you would find LCD video walls. So it definitely is not suited for this sort of application. Lastly is the haze level. Now, what you guys can't actually see is there's a whole bunch of studio lights that's around me, and haze level refers to the ability of the screen to reflect and diffuse the ambient light around it. So you'll see from the image on the screen at the moment is that you can't actually see most of this ambient light because it's quite a high quality screen that is doing a really good job of diffusing the light rather than reflecting it right back at you.